All right, in this lesson, we are going to finish particle motion. So we're not going to be finished because you will see this coming back throughout the year, but you will have all the tools and vocabulary you need to answer any flavor of particle motion question that might show up on the AP exam. So we're going to start by introducing some new vocabulary. Physics people, this will be familiar to you. Then we're just going to review our notation a little bit, and then we're going to tackle some more challenging FRQ style questions, some of these involving our new techniques of integration. Okay, to explore this new idea, again, physics people, I bet you know where I'm going with this. We have this table of positions versus time, and the question, I'm pacing around like a crazy person. The question is, how far do I get? Oh, that's a typo. I'll fix that on your notes. From t equals 0 to t equals 4. Well, here's 4, here's 0. That would be 18 feet minus 2 feet is 16 feet. Okay, so I made it 16 feet, right? So that would be something like this. So 2 feet to 16 feet, or to 18 feet. So that's my distance, right? But really, what I actually did is I didn't go straight there. I went this way and then back this way, right? And then ended up at 18 feet. So if I measured the distance of this actual line, it would be a lot longer, right? So that is this second question, right? How far did I actually walk? Well, 4 feet in the first second, then 2 feet in the second, then 2 feet in the third second, and then 16 feet, I must have been running or something, in the last second, right? So how far did I actually walk would be 4 plus 2 plus 2 plus 16, 24 feet. So we need names for this, right? So these are clearly different measurements. How far I actually walked, well, this has a name that's like pretty similar to what we might just call it in everyday speech. This we'd say is total distance, right? That makes sense. It's the total distance that I traveled, left versus right. This difference, though, this has a name that is a little bit more academic. This is called displacement. So this is really means like how far did you travel? Or even better than how far did you travel is how far did you end up from where you started. Whereas this would be just how far did you walk, okay? So as we know, integrals give us sum totals. So these vocabulary terms will connect specifically to integrals in a way that we'll see later. So notation-wise, we have position being x at t, velocity being v at t, and acceleration being a at t. And we know, right, that to go from position to velocity or velocity to acceleration is a derivative. Now, we can also go the other way. So to go from acceleration to velocity or velocity to position, an integral. And our units work the same way, but in reverse. So now we have the power to tackle some pretty complex questions here. This is an old FRQ. This is from like the 90s or something. And we have v of t is equal to sine of t squared. And we're also given, this would be a good thing to annotate, an initial position, right? So here we're asked just to find the position of the particle at time 3. Well, the position of the particle at time 3 would be its starting position plus the total change in position from 0 to 3. So this would be 5 was my x of 0 plus that integral from 0 to 3. So what I've done here is I plugged my function into my y equals, because we're going to use it a bunch, obviously. And then I'm going to do 5 plus my math 9, my integral button, and just use my stored function here. So this is, again, a very easy question. And I'd say 5.774. And I would double check that there's no units. Usually there's no units in these problems for some reason. And that's it. Now I want you to annotate that this integral here Well, this is an idea that I introduced earlier. It's the total change in position, which is displacement. Okay, so now we're going to tackle some trickier ones, and I'm going to rely really heavily on my graphing calculator for some of these. So the first thing I'm going to do is I'm going to change my window to what it's given, 0 to the square root of 5 pi. And notice this never gets any bigger than 0 or 1. So I'm going to change my y min and my y max as well. And then I'm going to get a graph that is essentially the graph that's given to us. All right. And I'm asked to find when the speed of the particle is equal to 0.5. Well, speed we know is the absolute value of velocity from our previous work. So I'm going to change my function in the grapher to the absolute value of velocity. And the way I'm going to do that is I'm going to go actually to y2. I'm going to do math, go over to numbers, and get absolute value. And I'm going to make that the absolute value of y1. And then I'm going to go back up to y1 and just deselect it. And then regraph. And notice it gives us this guy now. Which, if you know what absolute value means, that makes a lot of sense. Right? Now, I want this to be equal to 0.5. So I'm going to also graph that line. And if we want the time, the first time at which the speed is 0.5, it's going to be that first intersection, right? So I'm going to do second calc intersection and scroll over to it and then hit enter again, and it's going to spit out that value for me. So 0.724 seconds. Okay, so that was a question I only could have answered with a graphing calculator. My average velocity now, we just did this, right? So 5 pi minus 0 goes in the denominator. And then we want the integral from 0 to 5 pi of v of t dt, which would look like this on my calculator. V of t is y1, and it has to think quite hard for this one. There we go. That is my average velocity. So I'd say it would be equal to 0.040, I could say. And again, I don't have units for v, so I don't need to worry about units here. And then finally, the total distance traveled. So this is a new idea that we tackled up here, the total distance. The total distance would be the integral from 0 to 5 pi. And distance, we don't care about the direction. We will take the same value going left versus right. The way we represent that is we take the absolute value of these. So it's the integral of speed. Proving that is outside the scope of this course, but it makes some intuitive sense to me. So here I can do the integral from 0 to 5 pi, and then I can go math, and then over to absolute value again on the inside, and then type in y1, and this will give me my total distance traveled. And I'll spare you from having to watch the calculator think for a long time. You get 9.763. Okay. As is before, we have a couple new terms to add to our glossary, and then you are officially a particle motion expert.